Hello everyone, my name is Fuyan Bian. It's my pleasure to introduce our recent research on the most massive supermassive black hole at early epoch of universe using SkyMapper survey. In the past 2 decades, our understanding of high-range quasars has been tremendously improved. Especially, we built up a large sample of quasars beyond redshift 5, even a sizable quasars beyond redshift 7. This quasar tells us that a billion solar mass black holes do exist at early epoch of the universe. Here I'm showing an example of 1.45 billion solar mass black hole at redshift 7.5 from Jin Yang's 2020 paper. Using these quasars, we can build up the quasar number density function as a cosmic time, which can help us better understand the supermassive black hole accretion history. And to study the quasar host galaxy, we can better understand the co-evolution of black hole and their host galaxies. And these quasars also shed light on the reionization process of the universe and the formation of the first large-scale structures. In this study, we use SkyMapper survey, which is a deep multi-epoch, multi-color digital sky survey covering the entire southern sky with U, V, G, R, I, Z, these 6 bands. The survey depth is about 20 to 22nd magnitude. Using this SkyMapper survey, we try to search for ultraluminous quasars in southern sky. And we combine the traditional color selection, including the white and the SkyMapper color, and the Gaia proper motion and the parallax information. In the left plot, I'm showing how the Gaia can help us to get rid of the foreground contaminations from stellar sources. The solid line here shows the total number density, the total sources density on sky, and the dashed curve is showing that when we remove all the sources with parallax and the proper motion, which we can get rid of 3 order magnitude foreground sources, which are the contaminations for our quasar selection, that significantly improve our quasar selection efficiency. Using these 2 methods, we finally select about 90 quasars in the redshift range between 4 and 5, and with the extensive spectroscopy follow-up observations, we discovered 21 new quasars. In the bottom right plot, I'm showing the solid dark data points are the distribution of our quasars in the redshift and the absolute magnitudes. This plot is showing that our new discovered quasar basically double the sample size of previous known quasar in this redshift and luminosity range. Then we, for most of these quasars, we are carrying out a spectroscopy follow-ups using X-shooter and Keck-Nearest. Here I'm showing some of our first results, which combine the observation of the X-shooter and the Keck-Nearest spectrum of one of the most luminous quasars in our survey. And with this high signal-to-noise spectrum, we can fit the magnitude 2 emission line very well, including a power law to fit the quasar bright continuum, and the ion complex, and using a Gaussian profile for the magnitude 2 emission line. And with this well-constrained emission line width, we estimated the quasar black hole mass is about 34 billion solar mass. The quasar is at redshift 4.7, and which place this quasar as one of the most massive supermassive black holes at redshift 4. Here is our conclusions. Our SkyMapper survey has significantly increased the sample size of the ultraluminous quasar at redshift 5. And the spectroscopy follow-up observations reveal one of the most massive black holes at redshift, beyond redshift 4. The black hole mass is 34 billion solar mass. And please keep tuned our ongoing extensive spectroscopy follow-up on these bright quasars. Thank you.